Good morning, everybody. Thank you for attending the second in a four-part series, Theory, Method, Development, and Maintenance for the M7600. Again, thank you for attending. So a little bit about Teledyne Labs. We develop instruments for mercury analysis. We provide customers with a choice of mercury systems to meet their analytical requirements, and our mercury systems are based on the mature, time-honored cold vapor atomic absorption spectroscopy. The Hydra 2 and the Quick Trace mercury product lines are designed to cover a variety of techniques and digest matrices, and they will meet the stringent requirements of your US EPA and European norm methodologies. Some of our customers include laboratories in academics, environmental, food, petrochemicals, agricultural, mining, energy, pharmaceutical, nutraceutical, water and wastewater, to just name a few. A little bit about the cold vapor atomic absorption spectroscopy. Sorry about that. A little bit about the cold vapor atomic absorption spectroscopy. In 1968, it was developed by Hatch and Ott on the heels of first commercially available atomic spectrometer. Their work described a flame device that would get attached to a flame atomic absorption system, and it enabled oxidized mercury, Hg2+, to in solution to go from that to the ground state, and then it would transport up to an optical cell. So it's there was no heat involved, but it was just an optical cell, and they would measure the absorbance of the system. And this very quickly became the standard practice for mercury analysis throughout the industry and throughout the world, and the EPA adopted it after 1974 for 245.1 or for your water analysis. The M7600, Teledyne Leeman Labs creates this system, and this is our most versatile cold vapor atomic absorption system. Detection limits of less than 0.5 nanograms per liter in the most sensitive mode. It's acceptable for EPA 245.7. It meets all the criteria. 5 mils of sample in less than 90 seconds will give you a method detection limit of 1 nanogram per liter. And the usable range is from 0.5 nanograms per liter to greater than 500 micrograms per liter without any software changes. It employs double beam optics, lamp stabilization, and the lamp stabilization is a thermally stabilized lamp compartment. We also employ feedback for monitoring the lamp. It's called the optical feedback monitor, electrical optical, EOFM for short, for an acronym. Automatic adjustment of the lamp energy as the lamp ages, so this will keep your method detection limits and your instrument detection limits at a steady state during the lifetime of that lamp. The carrier gas is also computer controlled with a mass flow device, and you can either use argon or nitrogen. The 7600 base design is for EPA 245.1. Again, that goes back to the Hatch and Ott, the whole theory there. It's applicable to methods that typically require sample digestion. So the post-digestion acidified aqueous samples will be, mercury will be present in the +2 in that oxidation state, and that's introduced to the system with or without automation. So the digest sample must have Hg2+, and then we reduce it, stannous chloride, or sodium borohydride, and the incident light source is at the standard mercury wavelength of 253.652. So the carrier gas flows to the gas liquid separator through the reference cell. So it's a dual beam system. So here we look on the schematic here. So that's coming from the gas regulator through the reference cell and then down and over to the gas liquid separator. So then the satisfied sample is introduced by a parasolic pump, and it's got to be Hg2+, so it's dissolved in solution. And at the same time, the reducing agent is introduced by a parallel parasolic pump channel. And then the reducing agent is typically we use 10% stannous chloride and 7% HCl. You can work with other concentrations as well, such as you can use an alternate sodium or potassium borohydride. But in EPA 245-1 and 7470, stannous sulfate was first used with that method, but it's not recommended. It precipitates out, so it's not a good thing. So here's the stannous being introduced. The sample and reagent streams then join at a mixing tee, and immediately after the mixing tee, they enter a mixing tube reactor, where the stannous, almost instantaneously reduces the Hg2+ to Hg0. So that's happening while it's en route to the gas liquid separator. So then the Hg0 is in excess stannous chloride, so that will enter the gas liquid separator, and the carrier gas is then bubbled through the gas liquid separator to extract a mercury vapor, and then the waste stream is pumped to waste. So the gaseous stream of Hg vapor is dried with a Nafion drying membrane that's proprietary by Nanopure, and then it's directed to the atomic absorption spectrometer cell here, which is the sample cell, and the gas is directed through that cell, and the absorbance again is at measurement 253.652. So the light from the mercury lamp then will travel through both cells simultaneously, so that we have a reference point for our background, which is the reference cell, and then the signal is detected by the detector, and its integration time and repeats for the number of program repeats you put in the software, and it will give you an absorbance, microabsorbance number. Moving along, quick software review. So we use QuickTrace software, and you open the executable or the shortcut to on the desktop. Software opens the sequence editor view UI. The lower status bar on that user interface has a warm-up time, and that allows the lamp and the optics to equilibrate. You can click out of this if you want to and bypass and just move right into the software. So this software is designed by the customer for the customer. We're constantly getting interest and feedback information coming from the customer, and there's multiple ways to accomplish the same task. You have the drop-down menu, the favorites bar, and throughout the software there's many places where you can right-click or left-click, and pop-up menus will occur, and you have a myriad of tasks on those pop-up menus that the software allows you to do. So on the menu bar, we're going to start with the file and work from left to right for a quick review, and then we'll get to the favorites bar. So under File, this is where you basically open a worksheet. So it's new from scratch, you can open an existing template, create the method, save, run analysis. You can also do new from, create a template, create the method, and then save the template for future analysis. Save as retains the calibration correlation from a worksheet, so you just save it to a new name, and you have the calibration from that worksheet. And then there's a lot of basic stuff, printer setup, last open worksheet, that kind of stuff. And import and export is also here, so importing and exporting from the LIM system. And there's other places we'll get to that too, and I'll show you that shortly. On the edit, now this is associated with the sequence editor view UI, and it has tools that help you with manual sequence input. You can copy, paste, insert, select, etc., etc. So under the view, then you'll have view sequence editor and view analysis. So these are also available from the favorites bar, and they look like these little icons right down here, and it gets to those UI. So right now you're already seeing that there's multiple places where you can do the same thing. Under log, this is associated with the analysis UI, and down here in the bottom left-hand corner, it records and enters everything that happens during the analysis run. So you can review it later, you can print it out, and this is all for data quality control. So you can export here, you can filter all data, results only, operator notes, add comments, and it can be accessed by right-clicking on the analysis data UI. So you just right-click and it pops up. So you can add a comment, and that'll capture and record any unusual analysis events during that run. So it's very nice for the technician and or chemist to communicate back and forth with the quality control personnel on what's happening with the data. And then also you can click on the event tab, and that will pop up a dialog right here with time, date stamp, and operator information associated with that event. On the Analyze tab, you can read a single sample, and the sample tube shortcut opens an interactive Autosampler guide right here. So that's really a neat feature. So you just point and click. You also have where you can start run hotkey, or you can just press the go button. You can stop immediately after sample, and then you can also auto zero the system. On the options drop-down menu from the menu bar, you can show Autosampler guide, and that's a color-coded guide that shows up on the bottom of the sequence editor, because that's where most of your samples are added via the sequence wizard or manually. So you get a nice color code of what's happening, whether it's sample, quality control, spikes, and so forth. So all these color codes will be active when it goes into the Autosampler guide. You can also print that guide as well. Take it to the fume hood so you can load your samples into rack, and then that helps with avoiding mistakes. Preferences is a system-wide defaults, and there you have calibration file, reports, and standby. Administration, that's your user access management. So that's where you give users rights of control of the software and everything that they can or can't do with the software. So under preferences, and then calibration, you can show concentration. So if you click on that, where it says right here, samples out, it'll show samples outside of the calibration range. On the actual report, you will not get a value. It'll just be O/R for over range if you click that, and that's global. So if it's above the calibration at any amount of microabsorbance units, you'll get that. And then file location, this is set to defaults wherever you store your worksheets, export files, template files, and what have you. And they can be anywhere on the server. The system doesn't care. Under preferences, it's reports. If you type your laboratory name in here, this will show up on the header page of your report. So that's kind of a nice feature. And then the standby, this is for end-of-run stuff. So the pump turns off, lamp turns off, gas features, etc. You can have all of them, any of them, some of them, part of them, it doesn't matter. And over here, rack locator, or the rack separator. This is for different countries if they want to use different icons to tell you where the racks and tubes are. So typically, here's how it works. So the first number is the rack number. So from left to right, 1, 2, 3, 4, depending on your autosampler. If you have a smaller autosampler, it'd just be 2. And then the colon is the separator, and then the number behind it is the test tube within that rack. So an example here, I changed it, and it pops up over there. Additionally, if you click Allow Editing, this is for on-the-fly programming. So once the system's running, you can add samples to the sequence, update your quality control all at the same time, move your QC around. It's all really cool stuff. The menus bar window. This is where you jump from some of the main, some of your favorites. So method editor, autosampler, sequence parameters, reporting options, notes, view results, and instrument. Here's view results over here, analysis. It'll show up with all the information on that sample. You can page forward, page backwards, get peaks, print preview, all that kind of stuff. And all the graphs in the software are interactive. You can right-click, move the graphs up and down, left-click, zoom, unzoom, and then also print from those. So it's really some nice features. So here I'm just showing on the favorites bar what these what these UIs are equal to. So everything's right here on the favorites bar. I typically use the favorites bar. I don't use the drop-down menu. On the help, it's HTML format. The splash screen, you got software version, system information. So that uses the information that's placed in the specify install hardware when you define the system. So anytime you want to talk to a service agent or a representative at Teledyne Leeman and they ask for your serial number, it's very quick. You just pop over to help, go to about, boom, it's right there. So you have your analyzer serial number, some legal notices, and that's where you can close that UI as well. Getting to the favorites bar. So file. So this is some of the same stuff that you could do under the main file, but here it's just short and concise. So create a worksheet, new from, and open. So the basic stuff that you need. New, this feature opens a worksheet folder location. You can choose quantitative or detection limit. That's the only place where you can get detection limit. Detection limit, it opens up a dialog where we have some basic detection limits from like the EPA. You basically can either put a calibration in and enter your concentration and then hit go, and it will do all the math and spit out the numbers for you. So that's kind of a nice feature. And then simply type the worksheet you plan to use, add a comment if desired, and save, and you're done. So now you've created a new worksheet. New from is where you open up a template, so all the timing parameters, everything is all set. You don't have to do anything. You just open it up, give it a new name, and save. And then you're going to do a peak profile, which we'll talk about shortly, and you're off and running. So it's relatively easy to do this. Also new from, we've entered in some getting started templates. So for each system, each analyzer that comes with the Quick Trace software, even the legacy systems, there is templates in there, and that will help reduce the learning curve and jumpstart your analytical methods. Favorites bar, here's some basic stuff. You got the saves active worksheet, print, and print preview. Reports, this is where you have printer setup. Worksheet, so you choose for reporting, choose a worksheet for reporting. Report settings, you can change settings and print at any time. Open up a worksheet, change any settings, and print it. The worksheets and all the data is there. It's all in the database. Nothing ever changes. Nothing is lost. Sequence editor view. So this is interactive, intuitive. This is where you enter the sample count. If you're not using the sequence wizard, right-click in the screen, you get the pop-up menu. You can change units of measure. So here's that screen right here, units of measure. You can add units. You can create your own. You have fill down. You have an interactive guide in the tube. So if you click here in the tube and then click it again, this little hot button will pop up, and you can go to the Autosampler interactive guide and click the tube number. It'll enter it in without having to type it. So lots of neat features, and they're kind of throughout all the software. So if you're unsure, just point and click. You can't hurt anything. It's all good stuff. So right-click on there, like I showed you, and here you can import the sequence. So this is how easy it is. So if you're in the sequence editor, you want to import the sequence, you right-click, and then this little wizard will pop up, and it'll step you right through it. So it'll give you how you can see your data is going to go in. It'll give you delimiters and all that, and it'll let you reconfigure this screen for however your quality control person sets up the database. So you can move sections around, and then it'll go into the software in the correct section. So it's really a nice feature. On the analysis view, you can adjust window sizes, right-click for pop-up menus. So here's everything you need to know. So on this screen, you can jump back and forth between instrument, sequence parameters, autosampler, all that stuff that makes the system run. You can unzoom, print and copy in the graphs, you can inspect the calibration, and you can enter your log information into the log report. So down here in the bottom, here is the graph from Inspect Calibration. I've just brought it full screen, so that's what you get. So you have more of an interactive experience with the software. Method editor, some basic stuff. You can file, save, print. Tools, there you define units, so that's the second place where you can define units and standard names. Conditions, so conditions, you have Autosampler and analyzer method and timing settings. So this is the basics for method development. So it's all interactive. You do a peak profile, you see what comes on the screen right here, and it's very easy to adjust your timing parameters and make this thing work. You literally can do method development in a matter of minutes. You enter standards, it's concentration, rack position, and QC tests, that's concentration and limits. So under tools, again, you can define the units, quantitation, you can use existing, you can create your own, like for example, milligram per deciliter, millimole per deciliter. This might be something that would be used in a blood laboratory. Weight, you can, same thing, you can use existing or create your own if you want to get into pounds or whatever, what have you. You have those options. And volume, same thing, you can change it from SI units over to English units, whatever you want to do. Standard names you can add, change names or add more description if you desire that as well. Under conditions, so the autosampler, this is where you set up your uptake time for the sample and then your rinse time. And then under the analyzer tab, over here, that's where you have the timing for the method. So baseline points, integration, replicates, gas flow, pump speed, and all that. And then also above the graph on this UI, here's a blow up of the favorites bar for that, and you can toggle grid lines, copy the graph to clipboard, print, unzoom, analyze single sample, that's your peak profile, stop, zero, copy time profile to the log. So when the peak comes up, and if you click on this button, it will move that over to your log. So quality control always has a visual of what you saw when you developed that method or ran that analysis for that customer. Under the methods editor, under the standards tab, you have calibration type, and there you can go normal, 1631, 245, 7, quantitation, peak height, peak area. For the algorithm, you can do linear, quadratic. Standards, number of standards, concentration, then that'll pop open the other part of the UI over here where you can add or delete standards, and then your error actions upon the calibration stop or flag and continue. Under standards as well, down in the bottom right-hand corner, this is really a neat feature. You can send an email if something happens with the calibration. So if it's paused, it'll send you an email. So that'll open up a little UI. You enter in your email format, and so everything that's associated with email, it will send you an email if you're on the internet. So that's kind of a nice feature. And then you can also pause after first calibration for confirmation if you want to. Under QC tests, this is where you set up all the limits and the concentrations for your quality control. So you just click in it, and concentration value, if you're going to have a plus or minus limits, that's where you'd set that up. Also, under specify limits, this is where you can set up your replicate standard, relative standard deviation. This will give you a value, for example, if it's above 100 microabsorbance units and you want 5% RSD, you add that. So if it's greater than that, it'll throw a flag. If it's less than that, the system doesn't care. It'll just move on. And also, if you check required detection limits and or instrument, it will give you a less than or equal to that value there. On the favorites bar, sequence wizard, this is where you enter your sample count, position, prefix, suffix, or ID increment, specify weight, volume, insert calibration, and so forth. So that's all the information that you would need to enter and generate a sequence. So you can pull in the calibration, and then you just right-click and enter the sequence, generate the sequence. Sequence Wizard, under Auto QC, limit QC, you can calculate the volume, so you can limit the number of trips to, like, say, a 50 mil QC tube, and you can set that up so, like, if you're using 5 mils a sample, you could go back to the same QC maybe 9 times, 8 times, what have you, if you want a little bit of extra room there. And it limits the number of quality control you have to create, you have to load. And also, this is an interactive, so again, we're the Sequence Wizard Automated QC, so it's drag and drop. So yellow's up here, that's your quality control for your standards. Your quality control for your samples is down here, green, and on the bottom you can create your own. So right-click, set properties, and drag and drop your quality control down into here, and you could have set your frequencies as well. Under manual QC, what I typically do here is I set up the quality control to match the automatic QC, and then, because when you input information on the sequence editor right here, your quality control using the drop-down menu, that's what we refer to as manual. So if you input a QC here, this is the action that it will use. Autosampler. So here's our little icon for the autosampler right up here. Trying to get my mouse, well, there it is. And here you define the rack definition. So define rack size and rack type. Under sequence parameters, this is where you set up your smart rinse, overrange, your standby routine, so and the run like stuff, so lamp on, gas off, that kind of stuff as well. Post-analysis notification, this is a second place, so when the run is completed, you can, end of analysis or on air, again, you can send an email to yourself, let you know that something's happening. Reporting options. So here, this is for the active worksheet, and you can change reporting parameters right here, and content number format and things like that. You can auto report none after the run or export to. Notes, this is a nice feature over here, so you can add anything that is associated with the method and or sample sequence. If you have samples from a specific customer that have issues and they need a longer digest or so forth, you can have that information in here, so when the analyst opens up the worksheet, they can go to notes and look to see if there's anything specific about that sample set or that method that they need to watch out for. On the hot buttons on the menu bar here is a quick list here, so you can begin the run, you can do a single sample read from here, you zero the instrument, you can wet the gas liquid separator, that high gas flow, high pump rate. You can set gas pump. This is a startup icon to get the method going for what your parameters are. Set hardware automatically in the standby. Here you have your help, and here you can add an entry to the log as well. Another nice feature on favorites bar is if you right-click, you get these pop-up menu where you can add or subtract as many of these sections as you want. You can additionally, you can grab and move them around, so you can create that interface to look like how you want it to look. So your most active hot buttons can be over to the left, upper right, upper left, however you want to enter them. It's kind of a nice feature. So the instrument control maintenance log, this is for Autosampler. It's diagnostics only. You can move the probe, rinse, change rack size, and start strip chart recorder and so forth. Analyzer, the same thing, is diagnostics only. So you can turn the lamp off, gas off, pump off. You can calibrate the gas flow, but you got to have a flow meter that's calibrated to carrier gas. You can reset the auto integration, so that's after you clean the cells, you reset the drift baseline, and here you can also stop and start the strip chart recorder. Favorites bar. So this is serial numbers under maintenance will show up, and here you also have an instrument log. So it records maintenance and events and others. You can enter other or use the preloaded. So that again is instrument control, maintenance log, and we're over under the little tools icon. So that's kind of all the software really wrapped up fast in a nutshell. But it's really interactive, exciting stuff, so it's easy to navigate, and you can pretty much accomplish anything you want to do. Now, so quick trace startup. So this is really fast. So you inspect the pump tubing, lift the pressure levers, and feel each one for flat spots. Replace if you need to. Clean, rinse, and fill the rinse reservoir. I recommend, for PPB analysis, HCl, nitric acid, rinse maybe like a 2%, 5% is similar. It's really pretty forgiving system, so you don't have to sweat it. So inspect the GLS for cleanliness, inspect the position of the capillary, and to the naked eye it should look pretty much right on top of the center post. So once that's all set, you can make sure the tank pressure is set to approximately 125 psi. Turn the lamp on. After 15 minutes you can go into the instrument controls, record the lamp current in a logbook, start the strip chart recorder, inspect the baseline, make sure everything's fine there, make sure that all your tubing tees and everything is connected, empty the waste container, and then lock the pump tubing into the bridge stop. So even tension on both sides and into the first bridge stop. You want to insert rinse line into the rinse reservoir, insert the Stannis uptake capillary into the DI water. Again, ensure your waste reservoir is empty. Then you park the probe. That'll start filling the rinse station. Open the worksheet that you want to run new from, open, what have you. Click the startup icon. It'll set the pump rate and the gas rates to match what's in that worksheet. Engage the pump clamps, and then inspect the liquid flow to the GLS and from the GLS to the waste. The next step is to wet the gas liquid separator. So this is a patented design. It's a center post design, so thin film. So it's extremely efficient at stripping off the mercury and getting into the system. This is one of the reasons that our systems or the Quick Trace 7600 can get down to less than 0.5 nanograms per liter as an instrument detection limit. For a CVAA system, that's almost unheard of. So very quickly, place paper towel over the GLS exhaust, pinch the drain line down here. It'll start filling 1 to 2 bubbles to the top of the center post. You're done. Release the drain line and then inspect the liquid flows to the GLS and from the GLS to the waste. And then attach the Nafion. You're ready to rock and roll. So that method development. So what affects dynamic range? In a continuous flow system like this is gas flow. So high flows, short residence times within the sample cell, and that will give you speedy results, but it decreases sensitivity. You decrease the gas flow, your sample times become longer, but then it also increases the sensitivity. So if you increase the sensitivity, you're lowering your instrument detection limit, your method detection limit, and so forth. Pump rate also will increase or decrease the time to the GLS. So that helps you with your throughput, and it will also increase or decrease the mercury load into the system. Time and sample, same thing, increases or decreases the load, but you want to adjust it so it's a steady state for your method. So your signal plateau is flat, and your percent RSDs are good for the system. In most cases, the system will give you RSDs of less than 0.5%. I typically tell users that if it's less than 1%, you're fine. If it's less than 2%, you're okay. Once you get down into the sub PPT range, like 0.5 nanograms per liter, and in that range. Your RSDs are going to go up a little bit by default. It's just the way it is. So there you might be looking at 1 to 2%. So it all depends on the range you're working in. So a little bit about GLP. So you always want to wear gloves and clean as you go all day long. So I use the standards lid on, lid off technique. So what I do is I start with the blank, and then I add my makeup water, weak acid, 3% HCl, whatever I'm using. Add a standard aliquot. I like large additions. So if you're using a 50 ml test tube with a cap or volumetric flask, whatever, I do not like using 10 microliters, 50 microliters, 100 microliters into large volumes. That just introduces too much air. So I like large volume additions into my calibration standards. And then finally you add your digestion reagents. It's very important to matrix match. So in this case here, I'm going to look at developing a method from 0 to 1,000 nanograms per liter. So I just basically went new from, I pulled a high sensitivity method right out of the template, and I entered my standards, 0, 5, 20, 100, and 500, 1,000 nanograms per liter. Will that work? I don't know. I'm going to give it a go. But basically, when you become experienced with the method development, it becomes a second nature, and it's really, really easy to run this system. So what do? So we peak profile the high standard, and the system's pretty forgiving, so don't sweat it. So the pump speed's 100%, gas flow is 40, and this is the default method. Integration is 2.5 times 4 replicates, which give me 10 seconds. Rinse time to 100 seconds, uptake 65 seconds. Smart rinse, always have it on, but don't set it until after you know your response for your high standard. Peak profile, here's a 1,000 nanograms per liter or 1 ppb. The signal's still rising, so it's not the steady state. So now what do? Hey, let's get it faster, see what happens, move it to the systems faster, hit a steady state. So I'll go from 40 to 75 milliliters gas flow uptake. So I'm make it faster, so maybe I can cut back in the uptake. I don't know. Signal profile is not steady, but the RSD is really pretty good at 0.5%. And based on what I said earlier, that's not bad, but we can make it better. So here I change it from 65 to 50, gas flow from 40 to 75. The signal decreases slightly in response, but it's a nice peak shape. So now I'm just going to adjust the timing. Rinse from 100 to 85 seconds, first baseline, 5 to 10 seconds, second baseline, 125 to 130. And I can take my read and go from 53 seconds to 1.5 seconds times 4. So I'm moving it over in this range over here. So after that's set, it automatically gives you a new percent RSD. So it's at 0.15. That's fantastic. One more check. So let's reread the baseline and see if we're in a good time profile or if we can shorten it up a little bit. So here the baseline is 125 to 30. We're flat. So I can move it over to 110 to 115. Therefore, I can take the rinse time and go from 85 to 70, and I'll stick with peak height and linear. Now my total analysis time is 120 seconds. So typically you read another peak profile, and there you go. And then I'm going to read back some standards. So peak profile, it seems very nice and stable. Trust but verify. So sequence wizard, I'm going to generate the sequence, the calibration without a sample count. And in these cases here, I had my high standard to the left and my blank to the right. So it came over and then it worked this way. I mean, you can do it however you want. You can actually put your standards out in these racks, in the bottom racks. You can put them over here. You can do almost anything you want to with this system. So then I read back my blank, my 200, 20, 500, 5,000, and a blank. So on the readbacks, my calibration gave me 0.9987. That's pretty good. I had a problem with 2 coming in at 5.7 nanograms, but the rest of them came in pretty good. 100 nanograms was 100, 20 was 21.7, 500 is almost bang on, the 5 is a little bit high, the 1,000 is bang on at 1,010, and the blank came in a little bit high at 1.5. So the blank following the 1,000 didn't show any carryover, so what's my problem? The 2 nanogram following the blank definitely I had a contaminated tube. And then we're looking at a slightly elevated concentration for the baseline for the 5 and 20 due to the intercept. So here it is slightly below those, so that's why those are high. So if we look at what we can do, we can force through blank or get a better correlation. 1,000 or 1.00 would definitely fix the problem. But if we look at our readbacks, this is important. How stable is the system? So if the readbacks, you look at, for example, the 1,000 nanograms per liter at 31,499, my readback came back at 31,553. Those are almost bang on. And if you look at all of these throughout from top to bottom, they're almost identical to when they were with calibration. So my problem is definitely within the calibration. So quick discussion. Over range 0 to 1,000, it worked great. We can make a few changes. Plateau's kind of broad. Maybe we can go to 90 seconds. I could use force through blank. Maybe achieve a better calibration, a 1.0, but it's hard to repeat a 1.0 with each iteration of calibration. And also, it's very important to matrix match your standards with your samples, because we do know that kinetics will change the reaction, or will change the kinetics for the reaction of Hg2 plus to Hg0. Quickly, we'll look at 0 to 100. So this is where we would go when we're working at trace to ultra-trace analysis. And typically, if you want to analyze below a 10 ppt, 10 nanogram per liter, this is what you would use. So I followed the same, read the standard and so forth, opened up a method, set the pump speed to 100, gas flow 40, uptake 65, rinse, integration, peak height, normal linear, 2 minutes, 3% HCl was my rinse, 100 nanogram per liter peak profile, percent RSD is 0.19%. Great, that's a really nice peak profile. Run the sequence, and every time I do the readbacks, I like to mix it up to look for problems within the calibration. So, which I showed you in the 0 to the 1,000. So we saw a problem with the intercept. The correlation was very nice, but the intercept, when you're trying to do a large dynamic range, you have to dot all your I's and cross all your T's. So here I read back to 2, 50, 10, 5, 25, 100, and then the blank after the calibration, and look at this. My correlation was 4 nines and a 1. That's pretty awesome. Blank's flat and straight across. The readback was 0.16. Now, the 2 nanogram per liter came in at 1.96. That is really good. Obviously, I remade it from the last one, so we have a no contamination to show. The 50 is almost bang on. The 50, the 10 is great. Everything's well within acceptable ranges. For example, the 100 is 100.0, and then the second blank came in at 0.33. Look at the readbacks, the same thing. So here we have 45,953 for the 100, and on the calibration 4590. So these are almost identical numbers, and this is what you want to look for in your instruments. It's stable, yes, no. So when you develop a calibration or a method, do the readbacks of those standards to make sure they're coming in exactly the way they were when you calibrated. So now you're stable, ready to go, the method's validated, and then you can enter your samples and go with it. So the 0 to the 100 exhibited extremely nice linearity. Total method time is 165, but you're working with ultra-trace, so here you're going to charge more for those values, so it's acceptable to have a longer sample time. The readbacks are almost perfect. Now, this method is acceptable to 245.7. I just showed you a calibration point of 1.96 response for a 2 nanogram per liter with 120 microabsorbance units. Very discernible above the blank. So as long as you meet the quality control, which you can use it for 245.7. And same thing for the matrix match. Very important. So now we're into the standard drinking water, 0 to 10. To be analyzed for speed, I recommend if you're going to run below 0.1 on this range, you might want to use the different calibration 0 to 100. So I follow the same thing. My standards are 0.1 to a 10. Normal range, I'm using total linear 145 seconds. The pump speed, pump rate 30%. We should be able to improve this. I'm going to give you a quick synopsis on how we did that. Peak profile, adjust and calibrate. It's that easy. So everything is right here on the UI. You peak profile the standard. It's all visuals. You can move things around. You can grab the timing lines with your cursor. You can type them in here as well. There's lots of ways to make this interactive. So for example, if I want to move this, I would just grab it with the cursor and move it. And you can move it, and it's going to move it over here under this section of the UI. So my final method, so time's money, so let's get 145 seconds. And then so I set the pump speed to 50, so that was the first time, it was 145 seconds. Gas, I've moved it up. Microabsorbance went from 125 to 115, no big deal. It's 125,000, no big deal. I changed my uptake to 45, rinse time to 70. Now I'm at 120 seconds. My integration I set 1.5 times 4. The signal is very, very stable. So now we're going to run it through very fast, up to 10 for 2 minutes. Again, I do a calibration, correlation, intercept, system looks good. My readbacks go from there, 0.1, 10, 5, and again I like to mix them up a little bit. So here the 0.1 came in at minus 0.22, 0.01 I should say. The 0.1 came in at 0.06. The rest of them look relatively okay. The 0.5 was a little bit low, but still within 10%. So let's take a look and see what happened. It looks very nice, but let's see if we can reproduce or make it look better. Again, let's look at the readbacks. The readbacks are bang on, so that's not the problem. The problem is the correlation. So it was 0.992, which is good. Most labs would accept 0.997 or 995, but then you have to deal with what's happening under that correlation with the samples. So I took a look at it and I removed the 5 ppb standard, and I went from 0.999 to a 1.0, and then it flags the analysis result. So we went from 0.022 on the 0.01 to 0.04, or 4 nanograms per liter. The 10 came in closer, the 5, it really didn't affect it, but the 0.1 came in at 14% low. The 1 was almost right on, and it improved the 0.5 to 0.493. So you can do things like that within the software, and we still had enough calibration points because the method only requires, I believe, 3. So quick, it exhibited a nice linearity. Readbacks were acceptable. The 5 was slightly off, which skewed it. I removed it. It worked perfect. And again, matrix match. So here's the new calibration line down in the low end. Once I moved it, everything went right through the points. It was perfect. Here's the big one. So you may or may not ever want to do this, but if you do have high range samples, you can do it on this system. It's really, really sweet system, and so up to a 0.5 milligram per liter, 500 microgram per liter, no big deal. So, but I don't recommend going below a 0.1. And keep in mind that in any absorbance systems, once you start to get around 400 microabsorbance units or 0.4, you start to get into the nonlinear range. So you have to make a few changes. So my calibration is a 1 through a 500. I'm going to use peak area quadratic. I'm going to force through blank, and I'm going to use a 2-point baseline correction point. So my pump speed is 100% because I want to get it fast. I want it to happen really quick. My rinse is 100. My uptake is only 5 seconds. My rinse is 55 seconds. So I'm going to do all this in less than a minute per sample. So I run it. The sequence, my fit is 0.99949. That's really good. And then I do my readbacks. Now here's what the peak looks like. So it looks a little bit different than a peak plateau. This little blip up here is the air pulse coming through, and it's consistent throughout, so it works great. So I do my readback. So the 1 is 1.21, and 250 is 243, and so forth. And then the 0.1 comes in at 0.116. So you can read lower levels, but I don't recommend it. And all the rest of it is almost right on. And if we look at our absorbance, now here we're in area, so that's why these numbers are so huge. But for example, 19 million, and you look over here, 19 million, At the 10, we're 594,000. Come over here at 10, we're 564,000. Now this is no big deal because look down here at the blank or the 0.1 at 0.116. My absorbance down here is 7,876. So small differences up here or large differences is not that really big of a deal. So over that calibration range, it exhibited a nice fit. My total time was 60 seconds. The readbacks were very acceptable. And again, it's not advisable to run data below 1 milligram per liter. But let's just pop back here real quick. You can see that you can run it. The readbacks are good, and it's very easy to do. It took me like 5 minutes to develop the method, and away we went. Okay, so in discussion for this part, don't go below 1. A blank following a 500 might exhibit a little bit of carryover because that one blank came in at 0.453. I might be able to compensate for this by adjusting my rinse speed, rate, and or concentration of my acids. The 0.1 after the 100 exhibited little to no carryover, and the concentration came in at 0.116, which is pretty good. And again, matrix match is very important. So some of the shutdown. So what do we do to shut this system down? It takes like 5 minutes. 10 minutes max. Place the stannous capillary in a bottle of nitric acid, 10%, 10-minute rinse. Remove the rinse uptake from the rinse reservoir at that point, and then move the stannous to a DI water. Rinse that out, flush for a minute. Remove the capillary from the DI water. You want to run your lines, flush your lines to dryness. Raise your probe through the Autosampler, disconnect the Naphion. Turn the lamp off. You're not going to use the system, you can do a shutdown, but basically turn the lamp off and then turn your gas off at the tank, and then it's ready for the next day. And again, empty your waste container. Some basic maintenance. The gas liquid separator is pretty robust. Don't sweat it. Usually the daily startup and shutdown will take care of it, but if you need an additional online cleaning, you can use 50% nitric. 50 mils of that, followed by 20 mils of HCl and 20 mils of DI water. But remember, again, daily cleaning, startup, and proper shutdown goes a long way. If you need to clean it offline, I take it off the system and put it in a container, some type of plastic container, fill it with 50% nitric acid, put it in the sonicator for 30 minutes, rinse it in and out, and repeat with fresh acid. To get inside the system, I just use a pipette tip on a squirt bottle and rinse with DI water that way. Pump tubing, daily inspection. Okay, replace it flat, or they appear wear. And again, it's very robust, that pump tubing, so you should get greater than 100 hours of use if the tension is set properly. In the manual, there's detailed information on how to set pump tubing and also additional troubleshooting information and more tidbits on method development. It's all in there. It's written and very user-friendly. So again, replace the full harness. Ensure that the tension stays correct. And I always tell people, set it and forget it. Don't adjust pump tubing or pump tension for tubing that's going bad. You're just asking for problems. So leave it as is, change the pump tubing. So all three channels closest to the system should match because we use the same pump tubing, and the diameter of the stannous is a little bit less, so then we use less tubing there. Clean maintenance, cleaning the cells. You want to use IPA, cotton swabs, disposable beaker, powder-free gloves, purity wipes, and so forth. Wear gloves. Clean the cells first and keep your orientation the same for the cells for the reference in the sample, so left and right and so forth, and always wear gloves. So you want to clean the cells first, and then you want to go ahead and clean your end caps and your windows, and so they're ready to be placed on the end caps because those are cleaned first. And then you can blow off the fuzzies with about 5 psi or so from the back of the instrument. Disconnect that line. Be careful so you don't lose any components. Same thing for the cell windows. IPA, dry flush. Again, be careful so you don't lose the window when you're blowing them off. And then assemble each window and end cap after drying and in the same order you took it apart, and then replace the cell assembly. So in summary, the Quick Trace 7600, it's method development, it's quick and easy, good exercise, quick, easy exercise. It has an amazing group of dynamic working ranges. The manual is easy to read, lots of pragmatic tips for method development, and the manual has an extensive section on maintenance, daily, monthly, yearly, and so forth. So it's a nice tool to use, and then when you're working with this system. So a little bit about the next webinar, the third in the series of 4. It will be the M8000. We're going to talk about detection limits in the 245.7, 1631 compliance. I will review the software again. There's differences in the software between the M8000 and the Quick Trace M7600, and then again the patented gas liquid separator. So thank you for attending. That ends my part of the section. Again, thank you everybody for sitting through this hour-long webinar on the M7600 and method development.